So in the last class, we had discussion about numbers and we did a few problems on HCF and LCM, and we closed on the note that perhaps from this class we can start discussing powers and especially square roots and cube roots and how powers they interact and how powers they are solved. So the first thing that we have to notice for this is that if I write a number, let's say root 2. G. Can I express this number as a power of something? 0 to the power something, 1 to the 2 to the power? What would that be? 2 2s are 4, but over here it is root 2. It is not root 4. It is root 2. Can I write 2? Can I write this thing as 2 to the power something? 2 to the power 1 will be 2. That will 2 is not equal to root 2. 2 is not equal to root 2. Agreed? 2 and root 2. Hmm. Hmm. If I put, okay, root 2, it can be written as 2 to the power 1 over 2. Okay, root means power 1 over 2. Similarly, if I write root 3, it would mean 3 to the power 1 over 2. Whenever there is square root on something, this square root, it is equal to saying that this is raised to the power 1 over 2. Okay, you can check it on your calculator right now if you have it with you. If you write root 2 on your calculator, what's the answer that you get? And if you write 2 to the power 1 over 2, you should be getting the same answer. And 2 to the power 1 over 2? Ji, do you have a Casio calculator? ठीक है जी. You write 2, or you write 2 inside the brackets, and no root sign, just 2. Okay, one more thing to note over here, just this, and then I'll explain. Root 2 is equal to 2 to the power 1 over 2, but both of them, they are not equal to root 2 to the power 1 over 2. Please do not make this mistake. These two, they are equal to each other, and this is something different. So either we write the root sign or we write the power 1 over 2. One or the other, not both of them. Acha. So how to write this? So once you have written 2, then you write x box. There is an x box button just beside x squared button, right? That gives you the power, and in that you write 1 divided sign 2. Same answer, right? So that tells that under root 2 and 2 to the power 1 over 2, they're the same thing. And this is also the reason whenever you have got root something and you want to remove root of that thing, we square it. Did you know this thing? So for example, if I've got an equation x squared is equal to 4. Okay, how do I solve this equation? I say taking square root of both sides, and then so for example, if it were a bigger number, so if I say x squared is equal to 19982, now what would you do? Okay, so it would work for smaller numbers that you would directly know, but the method is that now in order to get rid of this square, what we do is we take square root of both sides. Okay, and how that solves the problem is because x square, and on top of that, if I take square root, that would mean I'm taking power 1 over 2. right? Are you following? And the other side, let me write as it is for now. What was the other side? 19982. Okay, and now if I solve it out, power on top of power, they multiply. Did you know this? So if I have a squared and then I take square of that, that would mean that would mean it is equal to a to the power 4. So when there is power on top of power, the powers would multiply. Okay, 6. Excellent. So if it is a, okay, one more thing, a good point raised. If it is a 3 to the power 2, it will become a 6, and it will also give the same answer if it is a 2 to the power 3. A squared to the power 3, it would, both of them, they would be the same. A cubed squared and a squared cubed, they would give the same answer. Okay, so that is why I told you that if I have got x squared and I take square root of that, so power on top of power, the powers would multiply, so 2 cancels with 1 over 2, it becomes 1, and the answer would be x is equal to under root 19982, and you can find that value in the calculator. Got it? So you write the square root button, 19982 is equal to, no, under root 19982, it should give 141.3577. You press the square root button, the square root button, and then you write 19982 is equal to. Okay, so this is finding square root. Achha, this is not something unique to square root. You know, the way there is square root, there is cube root as well. And the thing, it doesn't stop at cube root. We can have root to the root 4 or root 5 or root 6. So what that means is that, okay, let me write a few figures over here, and then we'll write them as power of something. Just a second. Okay, so I write under root 3, and then I write cube root of 3, and then I write root 4 of 3. Okay, so all these three numbers, if I want to express them as power of something, the first one I can write 3 to the power 1 over 2. The second one I can write 3 to the power 1 over 3. The third one I can write, 3 to the power 1 over 4. Okay, so it means if nothing is mentioned over here on this square root, it means 2 is over here. If nothing's mentioned, there is an implicit 2 over here. Okay, similarly, it could be a number or it could be anything. So for example, I can write x root of 3, x root of 3, and this, if I want to express it as 3 to the power something, it will become 3 to the power 1 over x. Simple. Okay, and then I say 3 to the power 1 over x, and the next step is, if I've got something, so for example, I have got let's say x to the power 4 is equal to 6666. Okay, and now I want to find value of x. So what I would do, I would take root 4 on both sides. Okay, so for math, this is something fundamental that we have to remember, and violating this rule usually causes students to make mistakes. Whenever you have got an equation, it means the left hand side and the right hand side of the equation, the two sides, they're equal to each other now. Now you cannot disturb one side of the equation without adding the same disturbance to the other side of the equation as well. Okay, whatever operation you apply, it has to apply on both sides. And sometimes we will see that, so for example, the first thing that I mentioned is that if I'm multiplying the right hand side with 2, I will have to multiply the left hand side with 2 as well. One example. Another example is if I am adding 7 to one side, I will have to add 7 to the other side. The same goes for subtraction as well. Adding, subtracting. Now the example of doing the operation on only one side, that is when what happens when, so for example, double six double six, can I multiply it with 1, and would that disturb the equation? It wouldn't, because the thing multiplied with 1 would stay as it is. So if I multiply one side with only one number, for this applies for just one number, 1, I can multiply 1 on any side of the equation and it wouldn't make a difference, because anything multiplied with 1 stays that thing, right? So that means for 1, I can also say I am multiplying it with 6 over 6. 6 over 6 is also equal to 1. So this is the only exception. When I am multiplying and dividing by the same number, I can do that to just one side of the equation, because it has the same effect as if I were multiplying that side with 1. This is the only exception. Otherwise, whatever operation we are performing, we'll have to perform on both sides. If we are taking log, we would take log of both sides. If we are taking a particular power, we'll have to take power of both sides. Acha ji. Now, coming back to the question that we had at hand. So, x to the power 4 is equal to double six double six. How can I solve this? By taking power 1 over 4 on both sides. Taking root 4 of both sides. Okay, so I can write this as x to the power 4 raised to the power 1 over 4 is equal to double six raised to the power 1 over 4. All right, and once you have it in this form, 4 cancels 4, so x is equal to double six to the power 1 over 4. And you know how to now put fraction and power, so you write double six x to the power on your calculator and 1 divided by 4. Hmm. Hmm. Nahi, just a second. Did I make a mistake? You put a bracket on the power. Hmm. Hmm. And then no. First the bracket and then 1 divided by 4. Acha, the other way to write this, if you wanted to write in this form on your calculator, 4 root of 6666, you can do that too. For that, you'll have to press shift and that x raised to the power box number 9.035. Hmm. Hmm. So you press shift and then you press this x to the power box. So that gives you that root with the option to write the outside number as well. So you write 4 and within it you write 6666. So that gives you 9.0357. Okay. This next arrow, this from this circle, press the next right side arrow. Acha. since we are learning the exploring the calculator, so one more thing, if you write double six double six and you press this x to the power box, now you have this fraction button, the button which allows you to write fractions, right? You press this fraction button and 1 by 4, that would give you the same answer. Okay, so these are all different ways of using your calculator. Whichever way you are more comfortable with, you can use that. Acha ji. Then a few more things with regards to power that we have to understand. Hmm. Hmm. We were talking about real numbers a class before. So one more thing to understand. Shall we discuss that right now or later? Right now or later? Okay, let's discuss it right now. Acha, if I have got root 4, what would be the answer? Is that it, or could there be another answer as well? No, how could root 4 be 1? I'm saying root 4 can be equal to 2 and root 4 can be equal to something else. So what is the answer of square root? Any number which I square so it gives back the same number, right? And why is the and why is the answer of root 4 equal to 2? Because if I write 2 squared raised to the power 1 over 2, this power cancel this, so it leaves 2 to the power 1. That is why the answer of root 4 is 2. For any number at all, if I write root 144, why would the answer be 12? Because this root 144 I can write as 12 squared to the power 1 over 2. 2 cancels 2, that leaves me with answer 12. Right? This is how I solve it. But is 12 the only number which when squared it gives me 144? The answer is no. Why? Because root 4 I can write it as 2 multiplied by minus 2 or 2 squared, right? Root 4. Are you following me? I can also write it as under root minus 2 times minus 2. Put that. I'm multiplying minus with minus. That would give me positive. So I can say both 2 squared to the power 1 over 2 and minus 2 squared to the power 1 over 2, they both gave me root 4. So it means when I solve root 4, I get two answers. Those two answers would be positive 2 and negative 2. ठीक है जी. At your level, अच्छा, first write this down, then I'll talk about the next thing. It might sound a bit tricky, so I encourage you to, after the class, look at this thing again, because personally I feel that we should develop concepts a lot good, and then any type of question that comes we can easily tackle that, as long as you are conceptually clear. So once we are conceptually clear, why is it that when I solve root 4 I get a positive answer, and I could have made you memorize that just remember that solving root 4 it would give you one positive and one negative answer, but what's the logic behind it? If you understand that, then it would be easier to memorize and apply this for the questions to come in the next classes. Okay, so similarly, just one last example and then perhaps we'll move to the next thing. If I've got x squared is equal to uh, 66, let's say. Okay, and now in order to solve both sides, I would say root x squared is equal to root 66. I'm taking square root of both sides. So for the left hand side, this square, it will cancel square root. So it gives me x. And for the right hand side, I can simply leave the answer as plus minus root 66. So if I hmm, hmm. So initially I had x squared is equal to 66. And now I want to find the value of x. So in order to find value of x, I have to get rid of squared that's there on x, right? I can get rid of that by taking square root. If I take square root of left hand side, I will have to take square root of right hand side as well. So I take square root of both sides. Okay. So for the left hand side, the square root, it cancels the square. The square and square root, they cancel each other because square root represents power 1 over 2. So 2 into 1 over 2, that leaves me with x. For the right hand side, it leaves me with answer root 66. Right? That root 66 we just learned, it could be positive root 66 and negative root 66. If I solve root 66 on my calculator, it would just give me the positive answer. But whatever that answer is, if I take negative of that and square that, that would also give me 66. A bit tricky to understand this whole thing. Hmm. Yes. Yes. And when we get to practicing the questions there, I'd be able to guide you better that this particular step, if you miss, how many marks you lose, and in which context you afford to miss this and which context you do not afford to. We'd be using this so often that it would become second nature to you. Okay. Everything about math, as long as you are giving it enough practice, you don't need to remember math, you just need to practice math. That's the point of all these classes that we'll be doing. Acha ji. And we have to remember this thing at our level, we are saying it applies just to square root. It wouldn't apply to cube root. Okay, cube root won't give me two answers. It would be just one answer. Acha, next thing, next thing. Okay, so we know that root 4 is equal to 2, or we can say positive 2 and negative 2, right? But root 4, we know it is equal to 2. What about root of minus 4? What would the answer be? Hmm. Okay. First, I'll give you directly the answer and then I'll explain you the whole logic behind it. So the answer of this would be 2 iota. We write an I. Okay. 2 negative. No, it's not an error. This is a type of imaginary number. So remember or the class before we discussed real numbers, and for real numbers we said all the rational numbers and irrational numbers together they form real numbers. And I told you that opposite of real numbers is imaginary numbers. So this is an exposure to imaginary numbers. That what sort of imaginary numbers? Now let's see the whole logic behind it, and perhaps that would make this thing a bit more clear. So if I have negative root 4, it is the same as saying that I've got under root 2 into 2 into minus 1. Can I write that instead of negative root 4? Why not? I just factorized minus 4. Okay. The next thing is I can write this as 2 squared into minus 1. I can also write this as root 2 squared into under root minus 1. And root 2 squared, that will be plus minus 2. And under root minus 1, this is what I call iota. So this is the whole logic behind that, why if we do root minus of something, it would give me that number and iota. Okay, so for this portion that we are currently dealing, some of it is in the algebra portion, some of that is in the numbers portion. Since we were already dealing with the squares and roots and things, so I thought it better to discuss it right now. But it's all there in your course, in your syllabus, the Cambridge Extended Math syllabus. Okay, you can check this with the syllabus guidelines as well. You can look for solving roots and negative roots or imaginary numbers iota. These things, they would appear up in your syllabus. Okay, acha ji. So now we know if we find a root of, acha, if I try it on calculator, under root minus 4, it would give me a math error for the reason that I am not in the correct mode. Hmm. Okay, on your calculator, the usual mode. Shall I tell you how to do it on your calculator? The proof of it? Okay. Just beside the on button, you have the mode setup button, right? You press that and then you press 2, complex number. Okay. And now you write under root minus 4. You press the square root button, the square root button that we have been using for the class. And within the square root, you write minus 4. Huh? Square root of minus 4. You press the square root button. Um, the second button, okay, just below calc, move 1 to the right. The, just below, just below calc, 1 to the right. G. And under root right minus 4. Within under root, you write minus 4 iota. So that's where the iota comes from. Okay. And you'd only be able to get it if you are in the complex mode. If you are in the normal math mode, okay, let's just set your calculator back to normal. So you press mode again and you press 1 comp. Okay, here if you do root minus 4, you'd get a math error. uh, we just know that if we have to, first of all, these questions, they would be simple enough. So for example, if I've got under root minus 16, without referring to the calculator, I know 16 is square of 4 and minus, that would give rise to root minus 1. So I would have, this would give me 4 squared time under root minus 1, so 4 iota. Okay, so for exam usually you would be dealing with numbers simple enough. Other than that, even for your exam, if you get a big number, so for example root 256 or root negative of 256, and you want to check it, so you simply find out the answer of root 256 and you put iota next to it to show that that's for the negative sign. Okay. Acha ji, anything else? Acha, let's do cubes now. Cube roots. So I have got cube root of 8. What would that be? You can check on your calculator as well. There are two ways. First, you press shift and the under root button. That would directly give you cube root. And the other method is you press shift and x raised to the power box button. Okay, it's 2. So now let's check on the calculator 4 root of 16. Hmm. Shift x raised to the power box. Okay, Ji, the answer would be 2. Acha, acha. Hmm. Come again, please. Okay, here is how. So 16 raised to the power 1 over 4. What number to the power, can I express 16 as some number raised to the power 4? Or I can say 16 is 4 times 4 to the power 1 over 4. So I can say 2 squared into 2 squared to the power 1 over 4. And since bases are same, when I'm multiplying these two numbers, their powers would add. So it would be 2 to the power 4 raised to the power 1 over 4. Okay. Acha ji, let's try a bigger number now. Let's say let's say hmm 5 3 2 7 6 9 7 6 8, I'm sorry. Root 5 of 3 2 7 6 8. Hmm. So 8 would be the answer. And if I need to know the working of it, it would be 8 to the power 5. On top of that, power 1 over 5. So these powers they cancel. I'm left with 8 to the power 1. Okay. Okay. One more thing regarding powers that we have to be clear about is 8 to the power 1 equal to 8 to the power 0? No. What is 8 to the power 1 equal to, and what is 8 to the power 0 equal to? Hmm. Any number, anything raised to the power 1 is that thing itself. X raised to the power 1 is X. Aisha raised to the power 1 would be Aisha. Anything raised to the power 1, it would be that thing itself. Got it? And anything raised to the power 0 would be 1. Anything at all. So 100 raised to the power 0 will be equal to 1. Sad raised to the power 0 will be equal to 1. Anything raised to the power 0 is equal to 1. X raised to the power 0 equal to 1. Anything at all. Okay. And you can check it on your calculator as well. Write 8 to the power 1. You'll get any number at all. You write on the calculator and then write to the power 1. It would be that number itself. And when you write the same number with the power 0, it would give you 1. So that tells us one more thing. So in maths, and this is something that would perhaps be more useful when we get to the topic of algebra, if we are given any standalone number, 7, 856, 224, any number at all, and we aren't told the power of it, it's automatically we know that its power is 1. And sure. Acha ji, a couple of more things before we move to the practice questions. Acha ji, today we have learned a lot about numbers, powers, roots, what they mean, and how to solve them. Acha, one more thing. If someone tells you or someone just writes 5 cubed, what does 5 cubed mean? Excellent. 5 multiplied by 5 multiplied by 5. Acha ji, if someone say negative 6 to the power 5, that would mean negative 6 times negative 6 times negative 6 times negative 6 times negative 6. Right? Acha ji, one thing we know, then when negative numbers they multiply with each other, that gives us a positive answer. And when a positive number it multiplies with the negative one, it gives a negative answer. So if I have got any negative number with a with an odd numbered power, for example 5, the answer will always be negative. So this is something that you can run as a sense check when you're solving the question, and for example on your calculator you put in minus 6 cubed and the answer is coming out as positive, you'd automatically know you'd have made a mistake somewhere, because a negative number cubed or raised to the power 5 or raised to the power 7 or raised to the power triple 1, it should give you a negative answer because it's multiplying in odd number of times. And any negative number at all, let's say minus 7 raised to the power even number, it should give you a positive answer because the number is multiplying itself an even number of times. So that would get rid of the negative sign and the answer would be positive. Easy enough? Acha ji. One more thing about the law of indices. If I've got fractions, so for example, uh, 8 over 4, if I say, the answer is what? Hmm. 2. Why is the answer 2? Can we prove that using the laws of indices or the laws of powers? Look over here. 8 is the same as writing 2 to the power 3, right? 4 is the same as writing 2 to the power 2. In a fraction, when there is something in the denominator and I move it to the numerator, its power becomes negative as it goes up. So this would become 2 to the power 3 into 2 to the power minus 2. Okay? And that would leave me with answer 2 to the power 1. And I know 2 to the power 1 would be 2 itself. Acha, let's solve a few questions now quickly. Just a second. Acha ji, here are a few questions. Let's try work them out. Okay ji, 6 to the power 4. Obviously, we can put it directly in the calculator, and if I'm trying to do it without the calculator, 6 into 6 into 6 into 6. And then I can tell 6 squared into 6 squared or 36 times 36. Right? You can write the answer directly. Okay, for the exam, here is a hint that works most of the times. Just look at the marks. If it's just a 1 mark question, there isn't really any marks for the steps. Either you get it right or you get it wrong. Okay, if it's 2 marker, 3 marker, then maybe there is some question of showing the steps, but for just 1 mark questions, you directly get the answer. Acha ji, similarly 3 to the power 5 and 2 to the power 4, you can do that using the calculator as well. And just to understand, it would be 3 multiplied with itself 5 times plus 2 multiplied with itself 4 times, right? Over here I have got 3 to the power 4 raised to the power 2. So if I want to do it in just, I can do it in 2 steps on my calculator. First I find 3 to the power 4 and then I square that. The other way to do it in just one single step is, I know there is power on top of power, so the powers, they would multiply, and this would be equal to 3 to the power 8. 3 to the power 8, 6561. The other way, if you do it, so you first find 3 to the power 4, you get 81, and then you square it, you get 6561. Got it? ठीक है जी. अच्छा जी, over here we have got 0.1 to the power 6 divided by 0.01. Acha, I didn't tell you the answer for that one. Chana, you can do that. Again, you can do it in one simple step in your calculator. You write 3 to the power 5 next plus 2 to the power 4. So it just appears like this on your calculator. Ji, press the next button on this circle. So that will bring you out of power down below. Otherwise, it would be just keep on adding in the power. Okay, so this is how you come down, and then 2 to the power 4, and then is equal to 259. Okay. Haan ji, it is correct. Acha ji, for this one, let's try using the fraction button on the calculator. So on your calculator, you have got this fraction button which helps you write fractions just below the calc button. So you press this, you write 0.1 raised to the power 6 divided by 0.01 raised to the power 4. 100. ठीक है जी. अच्छा. Hmm. Hmm. Okay. Acha ji, then we have got 2401. So we know how to write the 4 root. So shift x raised to the power box 4, right side arrow key, and 2401. Shift x box. Seven. अच्छा जी, 256. हम्म. 256 G. Root 8 of 256 would be 2. Acha, you should know how to solve these without the calculator as well. So let's just discuss those two. So for example, for this one, I've got 0.1 to the power 6. Sorry, again? No, no, there isn't. It just calculates and gives you the answer. Acha ji, so I can write this as 0.1 to the power 6 times 0.01 to the power 4. This is the same as saying 0.1 to the power 6 multiplied by 0.1 over 10 to the power 4, right? So that gives you 0.1 to the power 10 divided by 10 to the power 4. 0.1 into power 6, it will multiply by 0.1 to the power 4 over 10 to the power 4. So 0.1 to the power 10. This would be just a bit too cumbersome, but 10 to the power minus 4. And if I want to convert this into 10 power something as well, I write 10 over 100 to the power 10. This would be just too cumbersome. We can easily find on the calculator as well. Let's just leave the solution. I mean, we could finish it, but let's just stay with the calculator one. It would become too confusing. Acha ji. For the next one, 256. Acha ji, 243. 243. So first you find the root 5 of 243 and then you cube it. So you can do it directly on your calculator as well. You start bracket. Within bracket you write shift box 5 243 outside root bracket close and x box 3. So it gives you answer in just one step. X box 5 and then within root you write 243. You first go outside the root by pressing the next key, the arrow key, the forward arrow key, and then you press the close bracket again. X box. Charanji, this gives us the practice to use calculator as well. This thing without using the calculator, what would be the answer? The next one. Come on. What does root 9 mean? Root 9 means 36 to the power 1 over 9. No, 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 no. There is no other side. So let me write the question, root 9 of 36 and then 9. Okay. So it would mean root 9 I can write as 36 to the power 1 over 9, right? And outside power 9 stays as it is. Power on top of power, they multiply, they cancel each other out. The answer is 36. Didn't we just discuss that power, sorry, this root 3, it can be written as that thing to the power 1 over 3. So if it is a root 9, it's equivalent to power 1 over 9. So for example, this question, it was the same as saying 2 squared root. So now you know that this squared, it would cancel this 1 over 2. Anyhow, you'd get there with practice. Acha ji, 2 to the power 7 into root 1. Acha ji, what would this become? 2 to the power 7 into root 1 by root 4, right? And that would become 2 to the power 7 into root 1 over 2. And this 7 has got power 7, this 2 has got power 7, this 2 has got power 1. So when I bring this one up, it would be 2 to the power 6 times root 1. Root 1 would be 1. Sorry. Uh, as far as I remember, those questions, they used to appear back in the days, but now recent attempts, I think they have stopped giving those questions. I'll recheck and confirm. In the older times, there were such questions, but I think recently they have stopped giving such questions. There was a portion, solve this question without using calculator. I wonder if they still give those questions. That are there in the past papers that I tell you. In the past attempts, there those were there. What I'm saying is that I need to check if those are still given. Has Cambridge announced that they wouldn't be giving any such questions anymore? So that's what I need to check. Because in the recent attempts, from what I remember, I haven't seen those questions. So I need to go back to syllabus and confirm once more. Okay. Acha ji, let's just quickly. So this thing you can put in the calculator, or you can say this is 2 to the power 6 and this power. Acha, for 1 is the unique number. Whatever the root outside 1, the answer would stay as 1. So cube root of 1 would be 1, 5 root of 1 would be 1, 7 root of 1 would be 1. Any number at all outside in the root, for 1 you would get the same number. So this question, this 1, it would become 1. This 64, it is 2 to the power 6. So 2 to the power 6 into 1 over 6, this will become 2, the denominator. And 2 to the power 7 divided by 2, that would leave you 2 to the power 6, which is 64. So this question, it would have the answer 64. Okay ji. Acha, this one again 4, and on top of that there is power 1 over 4. So that would give you the answer just 5. The powers, they will cancel each other out. And when I say powers they cancel each other out, it means that they are leaving behind power 1. We know there is a difference between 5 to the power 1 and 5 to the power 0. So over here, what's left would be 5 to the power 1 and 5 would be the answer. Okay. And this one, something first root 10 and then power 2. So I can write it as 59049 into power 1 over 10 into power 2, right? So if you want to do it in reduced steps, perhaps on calculator, you can write this thing as 59049 to the power 1 over 10 to the power 2, and powers on top of each other, they multiply. So 2 ones are 2, 2 fives are 10. So you simply have to find the fifth root or root 5 of 59049, or 59049 raised to the power 1 over 5. Powers? नहीं, powers you write them as fraction. Mm, correct. ठीक है जी, that's it. चलें, as for the homework, let's see. There are without using calculator questions. I'll give you those as. Achha, you know how to solve the recurring decimal questions? Have you done those before? You haven't. Chale, remind me to begin the next class with the recurring decimal questions, and then onwards we'd move to the next topic. All right, ji. See you then. Assalamu alaikum. Homework. Good question. Just hold on, please. All right. चलें, जी, the whole thing. All right. Assalamu alaikum.